Let's have a look at the answer to question 2b, part 3. So we have data, and this is collected at a single-sex boys' school. And so we know that 15% of youths who eat breakfast daily have an intake of energy above 12,800 kilojoules at breakfast. So we need to suggest suitable values of the parameters. So when I'm talking about a normal distribution, the parameters of normal are the mean and the standard deviation. So this is the distribution we had previously been given, and I'm going to use this in a couple of ways to do this. So what we want to do is we need to use this information of 12,800 and the 15%, and we've got to suggest a model, a possible model. And so there are two things that we could do. We have to make an assumption, because those two pieces of information again by themselves are not enough. And that's why I need to use this information down here. And I need to make an assumption. And that assumption is either I'm going to assume that the mean is 11,200 kilojoules, or I'm going to assume that the standard deviation is 2,230. I need to assume one of those two things. And so there's two possible ways that we could get an answer to this. So I'm going to start just by doing the assumption of the mean. And I'm going to use that mean with the information above to work out what the standard deviation would be for that distribution model. So I am going to assume my mean is 11,200. I do not know what the standard deviation is. That's what I need to work out. But I have been told 15% are above 12,800 kilojoules. So here's my 12,800, and the percentage above that is 15%. So there is my X distribution. Now I'm going to match that to the equivalent Z distribution. It has a mean of 0 and a standard deviation of 1. And I'm going to find the Z value there, where the probability of being above it is this 15%. So it is matching to the X distribution. And so what this will do is it's going to find this 12,800, and it's going to find the equivalent Z value. Okay, these values are equivalent. Just like the means are equivalent and the standard deviations are equivalent. And the reason they are going to be equivalent is because of the relationship between these is our formula Z equals X minus the mean over the standard deviation. Remember, that is on your formula sheet. Okay, so I need to go and find the Z value. So that means that on my calculator, I need to go into the inverse normal mode. So that's what I'm going to do now. So get back out to there. So distribution, normal, inverse normal. Now the tail we've got there is on the right hand side. So that's fine. I've got right hand there. And I want the area to be 0.15 with now I'm going to set a standard deviation to be 1 and a mean to be 0. And that gets me a Z value there of 1.036. Okay, so that is my Z value. So Z is 1.036. So using that and my equation, Z equals X minus the mean over the standard deviation, I'm going to combine that together, substitute some values in. So I found that Z value, 1.036. The X value that it's equivalent to, remember, is that 12,800. the mean, which I've made an assumption about, is 11,200. And I don't know what the standard deviation is, because that's what I'm going to go now and solve to find. So, rearranging. 1.036, the first thing I'm going to do is this divided by standard deviation. Move that to the other side and it becomes times the standard deviation is 12,800 minus 11,200. And I'm just going to simplify this right hand side. 12,800 minus 11,200 should give us a difference of 1,600. Now I'm going to find the standard deviation. So now I want to remove the 1.3036, and the opposite of multiplying is dividing. So 1,600 divided by 1.036. And if I put that into my calculator, 1,600 divided by 1.036 gives me 1544.4. And this is talking about the number of kilojoules of energy. So that would be the standard deviation. So that means I could, for this situation, if I assume that the mean is 11,200, then my standard deviation would need to be 1,544 in order for the probability that we were given to be true. So that's one possibility. Now remember, I said that we can either assume the mean is 11,200 or we could assume that the standard deviation is 2,230. So that is the other way that we could go about this. So we could instead take our normal distribution where we do not know what the mean is. But if I assume my standard deviation is 2,230, then the other information we were given about 12,800, and this is being 15%, that would still be the same. And so I would then go and match that to my Z distribution with a mean of 0, standard deviation of 1, and to have this area of 15% is going to give me the exact same Z value, 1.036. Okay, so that's going to be exactly the same Z value as we found up here. Okay, so now what I need to do differently is my rearranging and substituting into the formula. So the Z value, 1.036, the X value it's equivalent to is the 12,800 minus, and the mean, I do not know what that is now, but I'm going to assume my standard deviation is 2,230. So this is what I'm now going to go and solve. So I'm going to do 1.036, multiply that by 2,230, and that equals 12,800 minus the mean. And I'm going to just grab my calculator to simplify this. So 1.036 times 2,230 is 2,310.28. Okay. Now I'm going to take this minus the mean, and I'm going to subtract that. Well, I'm going to move that to the other side of the equation, and it's going to become a positive. So I'm going to get the mean plus 2,310 is equal to the 12,800. And now I'm going to move this 2,300 across, and that's going to become a minus. So the mean is 12,800 minus 2,310.28, and that will give us, not that calculate this one, 12,800 minus, my answer was 10,489.72. and that would be kilojoules. So this is my other possibility, is that I have a normal distribution with a mean of 10,489 kilojoules and a standard deviation that I assumed of 2,230. Now both of those models will meet the criteria that we were told of 15% of youth having a daily energy intake of above 12,800 kilojoules.